Hello everyone, my name is Amira Darwish. This is Project 5 for Megatronics under Dr. Yasser Ismail. In this project, it shows the implementation of digital and analog sensors based on the provided videos. The digital sensor detects binary states, while the analog sensor measures continuous values. Each sensor set up functionality and performance testing and documented through the video with links provided in the report.
Hello, my name is Jared Sharper and our project is on sensors. This is the code that we used inside of PSI Creator to actually let the microprocessor process the signals. As you can see, we have to initialize the encoder, allow it to have a variable to hold the count, and wait for it to read the count and then display it on the LCD.
Demonstrating the encoder with the light signals. See that I have here in my hand, and with the switch turn of the black knob, these lights will represent ones and zeros. On representing as 1, off is representing 0. So as you see right now, both are set to 1, 1. And if I turn the knob just slightly, now it's representing 0, 1. Turn the knob more slightly, both are representing 0, 0. And keep turning the knob again, it'll be to 1, 0. So that's what is being demonstrated here with the encoder. Next, I'll explain the LCD screen and how that nature goes into the program as well. How you doing, everybody? My name is Langston Fogg. I'm a senior major in electrical engineering. Here in Project 5, I'll be demonstrating the encoder and the LCD display. Right now in my hand is the encoder, and what I'll be doing, showing a representation of the LEDs here on the breadboard. With the turn of this black knob here on the other side, it was light up certain ones or both will turn off, representing ones and zeros similar to digital logic. 1 represents if the light is on, off representing 0. So I'm gonna show you this real quick. So I will turn just a little, yes, kind of sensitive. Right now it's representing 1, 1. Turn a little bit more, representing 0, 1. Turn a little bit more, which would be 0, 0. And now I'll turn again, which is in 1, 0. So that's what's being displayed here today. Quickly, I'm gonna remove some wires and move into the pinpoints of 1.6, 1.7 for the LCD display. Here is the LCD display. As I turn, the numbers will decrease. And as I turn the other way, numbers will, well, this one would decrease, and I turn the other way, numbers will increase. So it's kind of tricky and sensitive on which way the direction will go. It's fine, my apologies. It was this right here piece that was supposed to be turned. So if, of course, I turn in a certain way, decrease, turn it the right direction, those will represent a different form. So as you can see, numbers can go as far as to the 600,000s and go to as little as 0, but of course if we get to 0.
Okay, and hello, my name is Jalen, Toaston, senior electrical engineering for mechatronics for Dr. Yasser Ismail. I'm going to be explaining the parts that were used in this project. Here we have our laptop, the code itself here. Here we have our breadboard, our PSOC, which handles the code and transfers the code. This is our USB port. This also is able to transfer the code from the laptop to the PSOC. We have our external power source, which is giving us more power to the PSOC to the breadboard as well. Our LCD screen here, which is displaying our values from our encoder, which is also used in this project. Our potentiometer, which is essentially the same thing as the encoder. It's just a different way to get our values and what we're trying to accomplish in the video. Our connection wires, which are used to establish connection and make sure that all our devices are synced correctly and make sure everything's operating correctly as well. And also, that is all. That is everything that is used in our video for our project.